Good evening, my dear students. So today we're going to start class 12th session, chemistry, and here you can see the chapter name haloalkane and haloarene. So before starting this class, I want to say something. See, organic chemistry mein, this is haloalkane, haloarenes, these are all purely organic chemistry, right? So one common problem in most of the students, those who are going to enter or who are going to start 12th chemistry, major problem is they forgot entire class 11th basic organic chemistry knowledge. And what will be the effects? The problem you will face this year, अभी 12th स्टैंडर्ड पे जितना भी ऑर्गेनिक रिएक्शन हम लोग पढ़ेंगे, मैकेनिज्म्स इन्वॉल्व होगा, कॉम्प्लेक्स रिएक्शंस होगा, तो वो अंडरस्टैंड करने के लिए वी मस्ट हैव दैट प्रीवियस नॉलेज. 11th का जो बेसिक था ना, उसको याद करना पड़ेगा. तो दैट्स व्हाई लॉट ऑफ स्टूडेंट्स दे फेल, दे फाइंड डिफिकल्टी इन केमिस्ट्री सब्जेक्ट. सो दिस इज आवर प्रॉब्लम. स्पेशली फॉर नीट स्टूडेंट, they always, there is one tendency is there that they always avoid physics chemistry. More specifically, they try to avoid. I don't know, this type of thing I experienced. But without these two things, without this physics and chemistry, and especially chemistry, because it is a scoring subject in NEET, without proper investment of your attention, you cannot improve chemistry. And this is scoring subject and it will give you a better rank. If you see, biology, almost similar marks. Everybody will get similar marks. Differentiating factor is this chemistry and physics. So that's why you have to manage. Somehow you have to manage this chemistry. How we will manage? So here the problem is you forgot almost lot of basics in or especially organic chemistry. Okay, so the solution is, every time you have to revise. You have to keep revising of all those previous topics. How we will revise? Every day just take one topic or two topics, or you can plan per week you will revise one chapter. Previous standard chapter 11th में जो भी chapters है, एक chapter को revise करो. Without revision, chemistry will become very tough for you. So today we are going to start our class. Although we are starting 12th, we need the entire knowledge of 11th class, right? So every day we have to revise past 11th standard topics, and parallelly, we will progress here. So this is the thing. So now our starting point is haloalkane and haloarene. So what do you mean by this? Haloalkane means here some alkyl group will be there, and halo means that fluorine, chlorine, bromine, iodine, means fluoro, chloro, bromo, iodo, this type of ions will be there, right? Means what do I mean? Haloalkane can be represented by Rx, where R is alkyl group and X is halide. Okay, fluoro, chloro, bromo, iodo, like that. So that's mean haloalkane or alkyl halide, both are same. Haloalkane or alkyl halide, both are same. Now here another term is there, haloarene. Now this arene word is coming from aromatic. Arene means aromatic ring must be there. Now if you consider normal benzene ring, yes, here we have this aromatic ring, correct? So this will become aromatic, means arenes. Not only this benzene ring, if you consider naphthalene, right? Big structures, naphthalene, phenanthine, all those big molecules where aromaticity will be there. So those will be under this arenes. But one special case if you consider where benzene ring is involved, so in that case we will consider phenyl halide. So phenyl halide and haloarene. Okay, so these two are correlated. Means if benzene ring is there, if aromaticity is there, then haloarene, obviously some halide must be there. If it is only phenyl ring, right, then we will call phenyl halide. Okay, these two names, haloarene and phenyl halide, so these two are correlated. Okay, so haloarene, it is a bigger category, bigger thing, and one part is phenyl halide, right? So now, so here also we can write ARX. Okay, ARX. Okay, ARX. X is represented, what it is representing, halide. Now come to our main part, classification. Classification. So on the basis of number of halogen atoms, mono, chloro, di, mono, chloro, di, monochloro, then dichloro, trichloro, polychloro, right? Now you can consider this trichloro as polychloro as well. Mono, di, tri, tetra, penta, like that. Okay. So now after tri, you can also consider poly. Poly means many. Many halide will be there. Okay. Now monochloro means only one. So just check here. Ethyl halide. Ethyl means, and also I know you have this idea. Mono means one. Mono means one. Meth means one. Mono means one. Meth means one. Di means two, and here eth also means two, right? So meth, eth, prop, but, pent, hex, 1, 2, 3, 4, 5, 6 numbering. Mono, di, tri, tetra, penta, hexa, these are also numbering. So in chemistry we need these two type of numbering. Meth, eth, prop, but, pent, hex, like that. Mono, di, tri, tetra, penta, like that. So both means 1, 2, 3, 4, 5, 6, like that sequence. Now just check, 2 carbon we have, so that's why ethyl C2H5. One important thing, if we have, let's consider CH4, this will be called methane, alkane, methane. If I remove one hydrogen, then CH3, that's mean alkyl, methyl. So here it is alkane, here it is alkane, and here we are getting alkyl or alkyl, whatever you pronounce. So alkane to alkyl, right? Similarly here we have 2 carbons, so that's why ethyl halide. Now if you consider this second structure, benzene ring, we have phenyl ring and 1 halogen. So obviously it is mono halide compound, right? So here also, so these two you can consider as mono. Next, di. Di means 2 halogen or halide must be there. So here you can consider this thing. Here we have 2 halogen. Based on this ring, aromatic ring, here also we have 2. So that's why dihaloarene. So ring means that common name arene is coming, and dihalo means 2 halogens or halogen atom or halide we have. Clear? Tri means, see this molecule, 3 halide will be there. Second structure based on arenes, here also we have 3. So basically these are basic classification, and here we have more than 3. So first example we have total 6, second example 4. Okay, tetrachloromethane, and here also we have total 6 chlorine. So more than 3, or you can consider that tri also as polyhalo compounds. So this is the basic idea based on number of halogen atoms, means that classification of haloalkane and haloarene. So next, out of those 4, mono, di, tri, then poly, out of these 4 classification, mono and di, these 2 are very, very important. In organic chemistry, multiple times we use compounds based on these 2, mono and di. So first let's consider mono halo compounds. So now just consider this one, sp3CX. sp3CX, what does it mean? If you consider any halogen X, if it is connected to carbon where the hybridization of carbon is sp3, and other will be like this, means total 4 bonds sp3, all will be single bonds. And second one, sp2cx. What does it mean? Here carbon must have one double bond. So this type of structure. So carbon is connected to halogen, and total how many sigma bonds it is having? 3 sigma. 1, 2, 3. Correct? So, and I think you already know how to get this hybridization. If there is only one sigma bond, then at least two you have to consider, then bond will be there. Now, at least 2 sigma bond, then sp. If 3 sigma bond we have, then sp2. If 4 sigma bond we have, then sp3, like this. Correct? So now just consider sigma bond. Pi bond will not be included in hybridization. So first example, here carbon is having 4 sigma bond, so that's why sp3. This carbon is sp3 and sp3 carbon along with this X. So focus on this bond. Here carbon is having how many sigma bond? 3. Right side 1, top side 1, 2, and left side 1, 3. So that's why this will be sp2. Correct? So this is the basic classification, means based on sp3 carbon and based on sp2 carbon. Now further classification we have. Based on this sp3cx, we have alkyl halide or haloalkane, allylic halides, benzylic halides. These are very, very important classification, because in organic chemistry, whenever we have some reaction, sometimes in the question they will mention alkyl halide. मतलब ये general name question पे दे देता है. तो if you have no idea what kind of structure it is having, how can you solve that type of question, right? So you must have the proper idea नाम के पीछे structure क्या है. यहाँ पे देखो alkyl halide or haloalkane. In this case, just we have to focus on these structures. First of all, monohaloalkane means only one halogen will be there. So everywhere, so whatever, how many structures we have, all these are, right? All these are examples. RCH2X. I think that one, first one, not this one. This is allylic. Wait. This is allylic. Okay, just check this first one. RCH2X. So here X is connected to carbon, and which is sp3. Now if we know the structure, then it will be much more clear, because another information we have: primary, secondary, tertiary, quaternary, this type of things we have. What is primary? Check here, R, C, hydrogen, and here X. Now just check, this X is connected to carbon. Now that carbon is connected to how many other carbon? Here R means alkyl group, means carbon is there, right? So that means this carbon is connected to only one carbon, other carbon, right? So that's why it will be called as 1 degree, primary. 1 degree means primary. Second one, carbon X, 1 hydrogen, and 2 R we have. R means carbon will be there. So here this halide is connected to this carbon, and this carbon is connected to 2 other carbon. So that's why it is 2 degree or secondary. Third one is this carbon is connected to other 3 carbon, right? That's mean this one will be our tertiary, means 3 degree. And 4 degree also we have, which is quaternary. So after this we will learn. So in new pentane we will get that structure. So basically, sometimes these are all general terms: primary, secondary, tertiary, right? Quaternary, and these things you have to identify which is having which degree. So these are all alkyl halide, simple structure, and all carbon is having sp3 hybridization. Come to this allylic halide. Allylic means double bond. Check this structure. So double bond here we have. Next, single bond, and this halogen is connected to this carbon. So that's mean halogen is connected to a carbon and adjacent carbon is having double bond. See the difference. Here double bond is present just next to the carbon which is containing halogen. So this structure, just see. Next carbon is having double bond. Here another structure we have, CH2X, and after this carbon we have another carbon, right? So this carbon is having double bond. So that's why this is also allylic halide. Allyl system is coming. If you consider this ring based system, this structure, here also you can see this double bond and these carbons 1, 2, 3. Okay, so this carbon is containing halogen, next carbon is having double bond, so that's mean allylic. This structure, here also you can see this X means halogen, it is with this carbon, and next carbon which is this, it is having double bond, so here also it is allylic. This structure, here also you can see big structure is there, but still here X, next carbon is this, and it is having double bond. So all these structures are connected to allylic system. All this will be called allylic system or allylic halide. Now if you consider benzylic halide, benzylic means pH CH2. Benzylic, it means pH CH2 or C6H5CH2, C6H5CH2 bond. This is benzylic. We have three terms: benzylic, benzyl, benzyl and benzo. So in case of benzylic, here we have CH2. In case of benzyl, one hydrogen will be replaced by R group, and in case of benzo, both the hydrogen will be replaced by alkyl group. Okay, so benzylic halide, it means PaCH2, this thing will contain halogen, correct? PaCH2X. Here also you can see pH, this carbon is there, and here we have X. So this is also example will be benzylic halide, right? And if you just last two classification based on sp2 carbon, Acha, here benzylic halide, so benzene ring, you have to focus on benzene ring. So here benzene ring we have CH2X. Next sp2CX. sp2CX means halogen must be connected to sp2 carbon. We have two systems, vinylic and aryl. Vinylic and aryl. Now vinylic means carbon is connected to a carbon which is having sp2, correct? Which is having sp2. So here also this system also you can see this carbon is having sp2 hybridization and halogen is connected to that. Then aryl halide means directly benzene ring is containing halogen, pHX. This is aryl halide. Again here you can see this is toluene system, it is having X, so this is also aryl halide. So basic idea is you must तुम्हें ये distinguish करना, you must have that skill which structure belongs to which category: alkyl halide, allylic halide, benzylic halide, vinylic halide, aryl halide, based on this sp3 carbon and sp2 carbon. I hope up to here it is clear. Next, dihaloalkane. Dihaloalkane means obviously two things will be there, two halogen will be there, and based on that we have vicinal, geminal and isolated. Vicinal, geminal and isolated. Now vicinal means adjacent carbon is having halogens. Geminal means same carbon is having two halogens, and isolated means totally two extreme end carbons must have halogens. So here we have some examples. So here adjacent, just you can write this thing, adjacent carbon is having halogen. So here we have one, this is one carbon, this is another carbon, just check back to back, this two carbon is having halogen. Now geminal means same carbon is having double bond, so this carbon is connected to this two halogen, so geminal system. Here also we have another example, this carbon is having top and down this two halogen, so that is also geminal system. Last one, isolated system, isolated dihaloalkane. So it means here we have say CH2 whole N, we have N means it can be any number, 3, 4, 5, 6, any number, And important point is, just check CHX and here CHX. Huge difference is there. Means we can say these two are totally isolated, right? So that's why we can say this one is isolated system or isolated dihaloalkanes. We can give another example also. CH2X bond CH2 bond CH2 bond CH2 X. So this is also, you can see, isolated dihaloalkane. Okay, so these are the systems: vicinal, geminal, isolated. Now after this, nomenclature. So whatever structures we have studied till now, how we will name, कुछ नाम तो होगा ना. Now chemistry में, स्पेशली ऑर्गेनिक केमिस्ट्री में, मोस्टली ऑर्गेनिक मॉलिक्यूल का दो नाम होता है, एक कॉमन नेम and another one is IUPAC name. So common name means common. Sometimes in questions they will frame common names, sometimes they will frame IUPAC name. So both the names you must know. So IUPAC name, that is the most important, because every time you will get some question based on that IUPAC nomenclature. Now it is a huge chapter, but I'm going to discuss in a brief way so that you can easily name this type of compounds, haloalkane and haloarene. First of all, how we will start? Find longest chain. First you have to find out longest chain. So longest chain means carbon sequence is there, carbon chain is there. So you have to find out in which way carbon is having maximum number in that parent chain. So longest chain, that must be your parent chain. Okay, that must be your parent chain. Second one, nearest locands. Nearest locands. Nearest locands or substituent. Or substituents. Or substituent. Nearest locands or substituent. What does it mean? It means, parent chain is, if parent chain is having some substituent like methyl, ethyl or chloro, bromo, iodo, right? So you have to consider that one. Nearest, which one is near? Third one is, if you have any double bond or triple bond, especially in this case double bond, because we have studied now, we have seen that sp2 carbon can contain halogen, so double bond will come sometimes. So if double bond is there, then double bond is having higher priority than halogen. Double bond is having higher priority than halogen. So if double bond is nearby, then numbering will start from that. We will explain all of this. So many examples we have, we will discuss all of them. Now fourth one is alphabetical order. Alphabetical order. What does it mean? Means if you have two substituent like chloro and bromo, two substituents we have, both are having same, at the same number, at the same carbon they belong to, then which will be the first, chloro or bromo? Then we have to remember alphabetical order. B comes first, then bromo first we will write, then chloro. So these four, if you remember these 4 points, you can easily name this type of compound. So one by one, so many examples we have, we will discuss that. So first one is longest chain. You have to count that sequence in such a way that longest chain you must get. Nearest locand, कौन सा साइड से नियरेस्ट लोकल लोकेंट्स और सब्स्टिट्यूएंट होगा ये देखना पड़ेगा. Double bonds and halogen, always double bond is having higher priority than halogen. Okay, next alphabetical order. Just remember this thing. If we discuss some problems, then easily you can understand. So let's say we have this type of compound. So two things we have. One is common name, second one is IUPAC name. How we will name? So let's see first example, then it will be clear to you. First example. So total how many carbons here we have? 1, 2, 3. Now how we will name? How we will give a number? See, substituent we have with this carbon, right? So how we will give number? How we will give number? So this will be our first carbon, this is second, and this is third, correct? So numbering will start from right side because right side carbon is having halogen or locant. I said locants, right? So that's why. So 1, 2, 3. 1 bromo, 3 carbon means prop, and this is alkane system. So alkane. 1 bromo propane. 1 bromo, this is our substituent. Prop is our parent chain, and N is our ending part since it is alkane system. So 1 bromo propane. And what is its common name? N-propyl bromide. N-propyl bromide. Both, any one of them they can give in the question. So N-propyl bromide or 1 bromo propane. Now if you consider second structure, this is very important structure. Sometimes this thing is there, sometimes they can frame in this way, like this. Okay, like this. So here CH2 CH3 and here carbon, and directly it is connected to chlorine. Okay, in this case iso, that iso word will be there. Iso term will be coming. Total how many carbon we have? 1, 2, 3. Now just check, if you give number from left side or from right side, both the cases substituent or locants will be at second carbon. So that's mean 1, 2, 3 or right side 1, 2, 3 both are same in this case. So 2 carbon is containing chlorine, so that's a 2 chloro, and substituents always must have this type of terminology: fluoro, chloro, bromo, iodo. And prop is the parent chain. Prop, parent chain is having 3 carbons, so that's why prop, and this is alkane system, that's why N. Okay, substituent, then parent chain means root word, then ending. That prefix, root word, suffix, already you know this one. Prefix, okay, next plus root word plus suffix. Okay, so this type of thing we have. So prefix means substituent we have to write, root word means that meth, pro, but, that thing we will write, and suffix means here that alkane, alkene or alkyne, that system name should be written here. Okay, so this step we have to follow. And that iso word, just now I said na, this isopropyl means 3 carbon we have, and if you have this type of structure we will call isopropyl and chloride, because chlorine is there. So this is very important. IUPAC name, if you remember those rules, you can easily recall, or you can easily find out what its IUPAC name. But this common name you have to practice, otherwise it is very difficult to remember, because so many things we have. Isopropyl chloride. So this is the thing. Now can you tell me what will be its name? Here just check. System is like that, like previous one only, right? Here we have this, then CH2, right? Here we have Cl. But if you consider this part, it is just like previous one, So again that iso word will be there. But here check number of carbon, how many carbons we have? 1, 2, 3, 4. 4 carbon. Here 3 carbons were there, that's why isopropyl came. Here 4 carbon is there, so that's why isobut will come. Isobutyl chloride, correct? And that IUPAC nomenclature easily you can give. Just check 1, 2, 3 this sequence, or 1, 2, 3, 1, 2, 3. If you put this number, or you can, if you put third one as this carbon, means on this carbon if you put third number, then that will be your substituent. So both the cases, 1 carbon, first carbon is having chlorine, so 1 chloro, and this will be your substituent, 2 methyl. Now root word is parent chain is having 3 carbons, so that's why prop, and this is alkane system, that's why N. So 1 chloro, 2 methyl propane. So see, I'm just explaining whatever we have. Now based on this I have a set of molecules, so there you will try to find out. So many examples we have. Now just check how we are getting names. Next, here we have another one. This is also very important. This is also very important structure. This is very important structure. Now just check. Whenever we have this type of system, this carbon is having another 4 carbon. So this is quaternary carbon, because the central carbon is having other 4 carbons. So this is quaternary, and quaternary means 4 degree, correct? Now this system, if we have this type of system, we will call neo. This new word will be coming. And how many carbon here we have? 1, 2, 3, 4, 5, total 5. So neopentyl chloride. Here common name will be neopentyl chloride. But if you consider IUPAC name, how we will do? So put number here 1, this is 2, and this is 3. And if you consider other way, you will get the same thing. Maximum 3 number of carbon in the parent chain. So that's mean 1 chloro, 2 dimethyl, 2 dimethyl propane, right? 1 chloro, 2 dimethyl propane. So this will be its IUPAC name. Just check here, already it is there. Okay, just check this name. 1 chloro, 2 dimethyl propane, and common name is neopentyl chloride. Just now I discussed this one. Now this last structure, what will be its name? Already I explained the same thing here. So this is like this, right? And this means iso, and how many carbon we have? 3. So that's why isopropyl bromide, and if we put number 1, 2, 3, so that's mean 2 bromo propane, 2 bromo prop alkane system, that's why N, 2 bromo propane. Okay, so here we have this 2 bromo propane. Okay, next, so up to here we have that basic idea that how this haloalkanes, we can give name for mono-halo compounds. Now di-halo compounds, where this is little difficult as compared to mono-halo compounds. Why? Because here we have specific name like this. Just check, gem dihalide. Already gem means we know same carbon is having 2 halogen, right? Same carbon is having 2 halogen or halide. And in that case, the general name will be having alkylidin halide. For gem dihalides, alkylidin halide. This will be your common name. IUPAC name means you have to follow that set of rules. 4 rules already we discussed. So from that you can consider. अगर एक कार्बन के साथ 2 halogen attached है, तो in that case this will be gem dihalide system. So common name होगा alkylidin halide. Okay, so one by one we will we have 1, 2, 3 examples. So what will be its name? Just check first one. 2 carbon we have ethylidin, alkylidin, ethylidin, ethylidin means 2 carbon, alkylidin, so ethylidin. In case of instead of alky, just put ethyl. Okay, ethylidin chloride, done. But what will be its IUPAC name? Just put 1 and 2. So 1 dichloro, because nearest substituent means from there numbering will start. So 1 dichloro ethane, 1 dichloro ethane. Now this system, can you recognize this system? Already I discussed this one. Whenever we have this thing, that iso system is there. So in this case, what will be its name? Always you have to consider this one, alkylidin system. So isobutylidin, just check. Isobutylidin. This system already I said iso system. Since 4 carbon we have isobutyl, and similarities must be with this alkylidin, isobutylidin, alkylidin, isobutylidin iodide. And what will be its IUPAC name? How we will give number? So obviously this will be 1, this will be 2, and this will be 3, right? So 1 carbon is having this 2 iodine. So 1, 1 diiodo, 1, 1 diiodo prop And since we have substituent, so 2-methyl propane, 1,1 diiodo, 2-methyl, prop is root word and N is alkane. Okay. So now if you consider this two nomenclature technique, what will be the name for this compound? Here we can say ethylidene because 2 carbon is there. In this case we have 1 carbon, so methylidene we can consider, right? Methylidene halide, X is general, so that's a methylidene halide. Can we consider that? No, in this case it is not following this rule. You can consider this one as exception because this is called methylene. Okay, this is called methylene, so that's why instead of methylidene halide we will call methylene halide. This is one exception, you must write this one. And what will be its IUPAC name? 1 carbon, this carbon is having these 2 halogens, so 1,1 dihalomethane, 1,1 dihalomethane. Clear now? Next, after this gem dihalide, we have vinyl dihalide. Now vinyl means adjacent carbons are having halogen. So here you can see this system, adjacent carbons, these 2 carbons are having these 2 halogen. And here also the same thing, adjacent carbon, so this carbon and this carbon, they are having halogen. How we will name this type of compound? So here see, IUPAC name is very easy. You can easily write this IUPAC name. For example, here 1, 2, 3. So 1, 2 diiodo propane हो गया. इधर में 1, 2, this one will be 3 or that one will be 3, and this 2 will be your substituent, right? This 3 will be your substituent. So 1, 2 dichloro 2-methyl propane हो गया IUPAC name. IUPAC name is very easy in this case, but what will be its common name? Alkyline halide. So in this case, since we have 3 carbon, so how it should be propylene, right? Propylene halide, correct? Propylene halide. Propylene halide means here iodide, so propylene iodide. And check IUPAC name 1, 2 diiodo propane. Done. So in this case, as I said, IUPAC name will be 1, 2 dichloro 2-methyl propane. But what will be its common name? So this system is called NEO system, right? NEO system. NEO system. Acha, this is chlorine. I thought this is carbon. Chlorine. So isobutyl system, because 1, 2, 3. So this system is like this. Instead of hydrogen, chlorine is there. Okay, instead of hydrogen, chlorine is there. So isobutylene chloride. So this is the system. And what will be its IUPAC name? 1, 2 dichloro 2-methyl propane. 1, 2 dichloro 2-methyl propane. So up to here, these are all nomenclature based on general compounds, general classification. Gem dihalide, vinyl dihalide. Then in case of monohalo compound, so we have this type of rules or compounds. Last one is this. Remember isolated system, I said isolated halide system means dihalo system. Now in this case, polymethylene, this methylene will be coming, and instead of poly, how many methylene we have, that thing you have to write. Okay, so methylene, CH2, always remember this is methane, CH4 is, this is methane, this is methane. CH3 if we have, this is methyl, this is methyl. If we have CH2, that will be called methylene, that will be called methylene. So these 3 things you have to remember: methane, methyl, methylene. Now just check here how many methylene we have. 1, 2, 3, total 3. So that's why 3 means in number how we will say trimethylene iodide, trimethylene iodide. And how we will put its IUPAC nomenclature? 1, 2, 3, 1, 3 diiodo propane, 1, 3 diiodo propane. Now in this case, how we will write their IUPAC name and common name? Total how many carbons we have? 1, 2, 3, 4, 5. Total 5 we have. So pentamethylene, right? Pentamethylene bromide. हो गया common name, pentamethylene bromide. And what will be its IUPAC name? 1,5 dibromopentane, 5 carbon. 1,5 dibromopentane. Okay, 1,5 dibromopentane, and that is pentamethylene bromide. Correct? So I think this is very easy. Now this one, what will be its name? If you compare these two systems, you can consider, sir, here we have 2 methylene group. So if we have 2 methylene group, so ethylene, dimethylene halide we should write, because here trimethylene iodide, pentamethylene bromide. So here dimethylene halide we can write, but no. In this case, again some exception we can say. So we will say ethylene instead of dimethylene. We will write ethylene halide, dimethylene halide. It will not be the correct answer in this case. So 1,2-dihaloethane. 1,2-dihaloethane will be its IUPAC name. So here nomenclature up to here it is done. Next we have this set of structures and their common names and IUPAC name. Always you have to go through, you have to be ready with this, because whatever we discussed, that thing and this thing both are correlated, almost same thing. I'm giving example, just check first one. So here we can use black color, white background. So just check this one. Secondary butyl chloride. Secondary means what will be its degree? 2 degree, right? 2 degree. Now secondary means, just check here, CH3, then CH2, then CH, here we have Cl, and here CH3. So this is the case. Now just check this halogen X is connected to this carbon, and this carbon is connected to another 2 carbon, right? Another 2 carbon. So that's why, since this carbon is connected to another 2 carbon, this is 2 degree, right? This is 2 degree. It is very bad thing. Let me write in a clear way. This is CH2, then C, here H, here Cl, and here CH3. So just check these 2 carbon. This is another carbon, this is 1 carbon, this is another carbon. Okay. So this halogen or halide containing carbon is connected to these 2 carbons, so that's why secondary. Now just check what will be its IUPAC name. So if you start naming from right side, 1, 2, 3, 4, longest chain 4 carbon. And why I am starting from the right side? Because see, second carbon is having substituent, nearest locants, that rule. If you start from left side, then 1, 2, 3, 3 carbon is having chlorine. And if you start from right side, second carbon is having chlorine. So which one will be the highest priority? Second carbon must have substituent. So that's why this is like that. So that's mean 2-chloro-butane. This will be your answer. 2-chloro, 4 carbon butane. So first one is done. Next, second one, what will be its structure? This CH3, this carbon is having CH2 and here Br, and this carbon is connected to other 3 carbon. Okay. Remember we studied this type of structures, neopentyl bromide. And what will be its IUPAC name? See the numbering. This is 1, 2, 3. So 1 bromo, 2,2-dimethyl, because both the methyl belongs to this second carbon. So 1 bromo, 2,2-dimethyl propane. 1 bromo, 2,2-dimethyl propane. Done. So this one is done. Next one. So this carbon directly Br, and here we have 3 carbon, right? CH3, CH3 and CH3. So in this case, if you give name, one central carbon is having first number, and if you put 2 here, then we are getting maximum number 2, but that's not the case. We have to get maximum number. So if you put this is 1, this is 2 and this is 3, yes, we are getting longest chain in this way, and this will be your substituent, this 2 will be your substituent, correct? So that's why second carbon is having bromine, one substituent, and methyl, second substituent. So that's why what will be its name? 2-bromo 2-methyl propane, because second carbon is containing bromo, second carbon is containing methyl. So 2-bromo 2-methyl propane, because 3 carbons we have in the parent chain. And what will be its common name? Tertiary butyl. Why tertiary? 3 degree. Tertiary means 3 degree, correct? And just check this carbon. This carbon is connected to another 3 carbon. If that carbon bearing hydrogen or bearing halogen, if it is connecting to other 3 carbons, then tertiary. So that's why it is tertiary. That is also done. Now this system, very, very important, this one. This is very, very important. Next one, CH2, CHCl. Now just check, this Cl is directly connected to double bonded carbon, right? CH2, double bond C, hydrogen, and here Cl. So what type of system we have this? This is vinyl system. Allylic means carbon containing halogen, adjacent carbon is having double bond in that case. Vinyl means halogen is connected to double bonded carbon. Halogen is connected to double bonded carbon. So vinyl chloride. Okay. And here what will be its IUPAC? Chloroethene. Now just check here. 1, 2. And if you put chlorine 1 or 2 means numbering, right side must have one number, first number, left side 2. So 1 chloro, eth is the root word, and this is alkene system. That's why in will be coming. And in this case, in case of eth system, if you put chlorine here and if you put chlorine there, both the cases, it means the same thing. So that's why one, if we don't write, both are same. So chloroethene will be the correct answer. This is very important. Okay. Next one, allyl system or allylic system. See, this bromine is connected to this carbon, and this carbon is connected to a carbon which is having double bond. So that's why allyl bromide, and already we know 3-bromo propane. So this will be the IUPAC name. Now this is the first time I think we are discussing aryl system. Aryl system or arene system. Just check, this is phenyl ring and we have CH3 group. So this is toluene system and one chlorine we have. Now just check, if we have this type of system, always remember with respect to this carbon, this will be called ortho. So how many ortho position we have? 2. This will be called meta. How many meta position we have? 2. And 1 will be para. And this carbon will be called ipso positions. In organic chemistry, especially in reaction mechanism, these terms will be very, very important. That is ipso position, 2 ortho position, 2 meta position, and 1 para position. So this whole system is called toluene. So that's why orthochlorotoluene will be its common name. Orthochlorotoluene. Now if I shift this chlorine into this meta position, we will call metachlorotoluene, and in para, then parachlorotoluene. That's all. And what will be its name? We have 2 ways. One is we can stress on benzene, or we can consider toluene as the basic system. In aromatic compound, we have this flexibility. If you consider benzene ring, so in that case, two things will be your substituent. In case of benzene ring, two things will be our substituent. Just consider this structure. So here CH3, this is one substituent, and one chlorine, this is another substituent. And if you put number, this is 1, this is 2, 3, 4, 5, 6. See, like this also you can consider. But remember, fourth rule, alphabetical order. If you consider alphabetical order, methyl starts with M, but chloro starts with C, right? C comes before M. So that's why this numbering will be starting from this chlorine 1, then 2, 3, 4, 5, 6. Numbering will be like this. Now you can consider, sir, why you are considering this left side, means anti-clockwise numbering. Why you are not considering this clockwise numbering? So reason is that nearest substituent, another rule already you have written, nearest substituent. If you consider right side, first carbon is having substituent, but 1, 2, 3, 4, 5, 6. Next, sixth carbon is having substituent. But if you consider left side anti-clockwise rule, first carbon is having substituent, as well as second carbon also is also having substituent. Means nearest substituent rule is followed in this case, right? So that's why 1, 2, 3 like this we have to consider. So 1 chloro 2 methyl benzene, because here the system is benzene. We are considering benzene as the basic system. But if you consider toluene as the basic system, if you consider toluene, this whole entire thing as the basic system, so in that case you must consider this toluene, this methyl containing carbon as the first carbon. Then second position is having chloro, that's why 2 chloro toluene. So this logic is very, very important and you have to understand this. Okay, so two names we have in IUPAC system. Next we have another one, benzyl system. So C6H5 or pH CH2Cl. So that's mean here we have one benzene ring and here we have CH2Cl. Already I said this entire system, this is called benzyl system. So we will call benzyl chloride, normal name, okay, or common name. And IUPAC name is chlorophenylmethane. How we will explain that? Just check. If you consider this CH2 group, this CH2 group with respect to this CH2 group, this chlorine will be your one substituent and this phenyl will be your one substituent. You can write in this way, CH2, here Cl and here phenyl, correct? So these two substituent we have, and this CH2 means, remember, methane. This is the starting point, right? Methane. That's mean one substituent name will be chloro, another one will be your phenyl, and methane. Alkane system, because there is no double bond, so alkane system you have to consider. So methane. So just now check. Chloro, then phenyl, then meth and N. Total 4 things we have. Why chloro comes first, then phenyl? Alphabetical order. Chloro means C, phenyl means P, chloro comes first because of alphabetical order. Chlorophenyl. Why meth? Because only one carbon. And why N? Because it is alkane system. Okay, chloro, phenyl, methane. So this will be its IUPAC name. Next one, if you consider this one, CH2Cl2, how we will name this CH2Cl2? Again the same logic like here we discussed. This carbon is having 2 chlorine and this is methane system, alkane system. So easily you can consider dichloromethane. Dichloro means 2 chlorine we have, and this is methane, alkane, methane. So dichloromethane. And its common name methylene chloride. Already I discussed this one. If we have only CH2 means methylene. So methylene chloride. And sometimes somewhere if you say methylene dichloride or methylene chloride, means the same thing. Okay. Next, this one CaCl3. It is very important. This one very important. Chloroform CaCl3. In so many reactions we have this as reagent. So this is chloroform. Trichloromethane, just like previous one. They are dichloromethane. This is trichloromethane. Okay. And last one, tetrachloromethane. CCl4, tetrachloromethane or carbon tetrachloride. Tetrachloromethane. And the last, this is 1, 2, 3. Total 3 carbon we have, right? Total 3 carbon. So first carbon is having fluoro. So 1 fluoroprop-N. 1 fluoroprop-N or N-propyl fluoride as common name. So this table, it is very important, because some examples, directly you will get questions based on this, and sometimes they will give common name, so you have to understand what will be its structures. Okay, so this table is very important. Now here we have a set of 12 molecules. We have to tell its IUPAC name. So first one, whatever we have discussed till now, based on that we can easily answer this. Just check. First one, if you give numbering from right side, so this will be our first carbon, 1, 2, 3. So third carbon is having double bond. But if you consider from left side, 1, 2, second carbon is having double bond. Remember, I said double bond is having higher priority than halo. So that's why 1, 2, 3, 4 and this is 5. Okay, this is 5. Now if you write the structure of this compound, CH3 bond CH, double bond CH, bond CH, and here we have CH3 and here we have another cell. So that's why 1, 2, 3, 4, 5. This is the system. Now chlorine will be our substituent. Now just check, fourth carbon is having chlorine. So that's why 4-chloro. There is no other substituent. That's why 4-chloro. In the parent chain, 5 carbons we have. So that's why pent will be coming, penta. And double bond we have. So that's why in will be coming, in. So 4-chloro, pent, 2-in. Alkene. So this would be its answer. 4-chloro, pent, 2-in. Okay. Now next one, first draw the structure, then you can easily understand that. You can easily find out its name. CH2 double bond CH, CH2 double bond C. CH2 double bond C we have. CH2 double bond C. Next there we have CH3. Here we have CH and CH3 and Cl. So this is the structure, right? Now from where you will start numbering? Again the same rule, double bond is having higher priority. First carbon is having double bond. So 1, 2. There if I write 3, then chain will end at number 3. But if I go that side, this is 3, this is 4. I can go towards fourth number. So this is longest chain. First rule, longest chain you have to follow. And here just check how many substituents we have. This one will be one substituent, this is another one, 2 substituents. That is methyl and this is chloro. So which substituent's name will be coming first? Obviously chloro. Chloro start hota hai C se and methane M se. So chlorine, chloro, it will come first. So that's why 3-chloro, 2-methyl, but, 1-in. Okay, just check. 3-chloro, 2-methyl, but, 1-in. Correct? So the same system, the same thing you have to follow in the next problem. CH3, next we have CH, double bond C, there we have CH3, correct? And here we have C, H, there we have CH3 and Cl. So this is our system. So how we will give number? Numbering is the important thing. From left side if you go, just check, second carbon is having double bond. From right side 1, 2, 3. No. If you start from this 1, 2, 3, 4, in this case maximum 4 you can go, right? But if you go like this 1, 2, 3, 4, 5, up to 5 we can go. So let's put number 1, 2, 3, 4, 5, correct? So here second carbon is having double bond. If you consider that side 1, 2, second carbon is having double bond, but in that case 1, 2, 3, 4, maximum 4th carbon you can get. But in this way you are getting longest chain, nearest double bond, okay, like that. So in this case how many substituents we have? एक substituent उधर और एक chloro. 2 substituents we have. Again the same logic like before. 4th carbon is having chloro. 4 chloro, 3 methyl, pent, 2 in. Just check. 4 chloro, 3 methyl, pent, 2 in. Done. Acha. Next one CH3, then CH, double bond C. There we have one CH3, and here we have CH2 Cl. This is the system. Now how we will put number? Just check. From left side 1, 2, second carbon is having double bond. From right side 1, 2, second carbon is having double bond. From this 1, 2, second carbon is having double bond. But if you put this number 1, 2, 3, 4, in this case 2 advantages we have. See, first carbon is having substituent, second carbon is having another substituent and also double bond, right? So nearest substituent already we have discussed. अगर लेफ्ट साइड से देखना है, so लेफ्ट साइड्स में ये 1, 2, second carbon is having double bond, but other substituents they are far away, right? So we will follow this number. So in this case how many substituents we have? Only 1, and here chlorine 2. 1 chloro, 2 methyl, but 2 in. 1 chloro, 2 methyl, but 2 in, correct? Acha, now next one. How we will put number? Just let's put number here only. 1, 2, second carbon is having double bond. From that side also 1, 2, second carbon is having double bond. तो नंबरिंग ऐसे ही होगा ना. इधर इसमें एडवांटेज ये है कि सब्स्टिट्यूएंट फर्स्ट कार्बन में ही है और सेकंड कार्बन इज हैविंग डबल बॉन्ड. सो बोथ एडवांटेज वी हैव. सो दिस विल बी आवर नंबर. सो दैट्स व्हाई 1 chloro, but 2 in, right? 1 chloro, but 2 in. This is the answer. Acha, next one, just check. Let's draw the structure. This first carbon is having double bond, and here 1, 2, second carbon is having double bond. 1, 2, 3, and this is our substituent with this carbon, and this is our substituent with this carbon, right? So what will be its name? 3 chloro, 2 methyl, prop 1 in, right? Prop 1 in or propane. So 3 chloro, 2 methyl, prop 1 in or propane. Okay, so this is our name. Now here we have few more structures. Just try to solve these questions. From left side 1, 2, 3, 4, 5. Maximum 5 carbon you can get. From left side second carbon is having double bond. From right side 1, 2, 3, third carbon is having double bond. So that's why 1, 2, 3, 4, 5, right? This technique we will follow. So in that case, this is our one substituent. Only one substituent we have. So 4 bromo, pent 2 means pent 2 in, right? 4 bromo, pent 2 in. Only step by step 4 rules we have, so that thing you have to follow. Next one, here numbering, first carbon is having double bond. So 1, 2, 3, 4, maximum 4 we have. So that's why 3 bromo, 2 methyl, 3 bromo, 2 methyl, but 1 in or butene. 3 bromo, 2 methyl, but 1 in. Acha, next one, second carbon is having double bond, and from that side third carbon is having double bond. So 1, 2, 3, 4, 5. So this is our parent chain, and how many substituents do we have? 1, 2. So 4 bromo, 3 methyl, paint, 2 in. 4 bromo, 3 methyl, paint, 2 in. Next one, second carbon is having double bond here, and there also second carbon. Just check, this is very, very important molecule. Just check, left side 1, 2, second carbon is having double bond, and there carbon containing or bearing bromine, that is 1, second carbon is having double bond. So numbering will start from right, 1, 2, 3, 4, correct? So in this case, this is bromine 1 substituent and that is another substituent. So 1 bromo, 2 methyl, but, 2 in. 1 bromo, 2 methyl, but, 2 in. Achha, next one, second carbon is having double bond, from that side also second. So 1, 2, 3, 4. There is no other substituent, except this Br. So 1 bromo, but, 2 in, very easy. 1 bromo, but, 2 in. And last one, second carbon is having double bond, but here first carbon is having double bond. 1, 2, 3, maximum 3. So 2 methyl, 3 bromo, 2 methyl, prop 1 in. 3 bromo, 2 methyl, prop 1 in or propene. So this is our discussion. See, haloalkane and haloarene, today whatever we discussed, basically what will be their common names, that classification based on that number, and so many examples we have. So that's why I use this type of information or informative slides. I hope all these ideas how to segregate different types of organic compounds, especially this haloalkane and haloarene, it will be easy. See, haloarene only ortho meta para, that is important. Okay, and in case of haloalkane or alkyl halide, how we will name, this is very, very important. Their common names and their IUPAC name. So this is under GOC. Already you have studied. I hope you have studied in class 11th. Just revise this whole part. This is only based on this alkyl group or alkane part, alkane or alkene. We have alkyne part, then all those functional groups, how we will name based on those functional group. Just keep revising all of that. Okay. So this is our Telegram app. If you just download this one, already you have Telegram, I think. So just join this channel. So you will get a lot of notes. Whatever we are discussing, you will get notes. Okay, so please join this one. And this is our YouTube channel. So we are going to live every day. We are going to discuss all of that. So you can subscribe this one. You can stay with us. Okay, thank you. So today we have discussed those two things. Please revise all of that. And next day we will follow next part. Okay, so how to prepare this haloalkane or haloarene. So that part will